Hello, Algebra 2. How we doing? Nice to see you. Let's jump right into it. Of course, we are looking at 8.3. I am recording this a little late and posting it a little late. I apologize about that. Things just get in the way, of course. There won't be a late penalty for this video if you're watching it late. I will be forgiving on this one, but hopefully you're at least watching it. You know what I mean? So here we are. What are we looking at? We're starting off by graphing angles. We've been talking about angles, but what is an angle? What are, well, obviously we know what angles are, but we're going to just dive deeper in drawing and sketching and graphing angles. Okay, so let's sort of dissect an angle. I found this tool online very quickly. It's not the best tool, but it's a decent tool. So this bottom side is called the initial side, and it's going to stay put. Okay, and this side that I'm moving is called the terminal side. And as I move the terminal side closer to the initial side, the angle, represented by the yellow arc there, is getting smaller. And as I move the terminal side, it begins to get larger. And now we're starting to form an angle that is almost 360 degrees all the way around. It's about to reset on me. Bloop. You see that? When it hits 360, then all of a sudden we're back at 0. When it hits 360, we're just back at 0. So we can go round and round and round. And when we go the opposite direction, this tool sadly does not go in the opposite direction. But when we go in the opposite direction like this, we're creating negative angles. So if you could imagine, this tool isn't perfect. This would be negative 90. And this would be negative 180. And this would be negative 270. And then a full negative 360 all the way back to 0, of course. Okay? So this is the terminal side that I'm moving, and this is the initial side. And we have things that are called coterminal angles. I wish this tool was a little bit better, but 90 is coterminal with negative 270 if I were to go all the way around negatively, right? So going in the positive direction and creating a 90-degree angle is the same thing as going in the negative direction and saying negative 270. We're going to end up in the same spot. Coterminal, meaning they are sharing a terminal side, right? This is the terminal side, and if you go 90 or negative 270, it doesn't matter which, it's going to end up in the same spot. If you just go around a full 360, you're always going to end up in the same spot, right? Here's a 45-degree angle, and if I go around a full 360, you're just going to end up in the same spot. So you can have angles that are larger than 360. That just simply means that you're going round and round and round. So going around twice is 720. Right? 360 plus 360. So you can have angles that are larger than 360. But the moment that you add 360, you're just going to end up in the same exact spot. And the moment you subtract 360, you're just going to end up in the same spot because 360 is all the way around. I hope that logically and visually makes sense to you here. So with that said, and these first few questions, I'm going to skip example 1 for a hot sec and go to example 2. When it says to find the smallest positive and negative coterminal angles, all you have to do is add 360 or subtract 360. Because by adding 360, you end up in the same spot and are thus creating a coterminal angle. Coterminal angles are angles that share the same terminal side. So by going a full 360, you're ending up in the same spot. So the smallest positive coterminal, you would take 230 and add 360. You get 590. The smallest negative, you take 290 and subtract 360. You end up with negative 70. Negative 100, you subtract 360 and you end up with negative 460. You add 360, you end up with 260. So on and so forth. 380, interestingly enough though, you don't add 360 to find the smallest positive. You subtract 360 because it's already over 360. When you subtract 360, you end up with 20. 20 is still positive. Then you subtract 360 again, and you end up with negative 340. See that? Let's go back to the sketching. I think you get the point on that. Let's go back to the sketching. Where's 135? Well, if this is 45 and then this is 90, then this is 135. We're just I'm in my head going 45-degree increments. 90 plus 45 is 135. So that is a 135-degree angle. And then negative 350, that's like going all the way around practically in the negative direction. That is negative 350. So negative means you go in the clockwise direction, and positive means you go counterclockwise. Okay, hopefully you understand there how angles can they're in the same spot, but by going around and around and around, it's technically a different angle, but yet it ends up in the same spot. So different and the same all at once. Okay, so this is the terminal side, and this is a point on the terminal side. We can create a triangle out of this, okay? That is 3 wide and 4 tall, and then we can use the Pythagorean theorem to calculate this hypotenuse, okay? That would be c. A squared plus b squared equals c squared, c being the hypotenuse. Why is this important? Because if I can, if for any angle that you give me a point, I can turn it into a right triangle, and all of a sudden I'm calculating sine, cosine, and tangent because I have opposite, adjacent, and hypotenuse. Fascinating, right? Just this random terminal side, the fact that you gave me a point allows me to create a right triangle, and therefore I can find the trig values. And that is quite valuable, okay? Trig values are quite valuable. So, sketch an angle theta in standard position and the given point on the terminal side of theta, then find the distance. I wish that was a little more specific, but we're finding the length of the terminal side. So if I plot 1, 2, 3, 4 to the right, up root 3, what does that even mean? Don't worry about it. Just pretend, right? We know that this point is 4 root 3. Who cares if we go up 4 root 3 accurately? I don't care. Actually, let me do that in a different color so it doesn't blend in. Every single time, this is going to be 4 wide and root 3 tall. I think I'm going to do 1 or 2 of these, and if you pay attention and you do it enough times on your own, you're going to realize you don't need to really draw this. This point alone is enough information. I know that the base of the triangle is 4 and the height of the triangle is root 3. I mean, that's honestly enough. So 16 plus 3 equals c squared. So this is 19. Take the square root. C is root 19. Again, if it helps to plot it, to visualize it, that's great. Here's negative 1, 2, 3, 0. Oh, this question, that's stupid. What's the length of that? Oh, 3. Right? It's not even going up at it. That's dumb. Right? It's not, there is no diagonal distance that we need to solve for. It's literally just a straight line that's 3 units long. Okay, skipping that one. Because we're trying to find the length of this terminal side. Okay? When it says find the distance, we're finding the terminal side. Okay? Or if you go back and look at these, I know I didn't read through this, but it's R. This is X, this is Y, and this is R. We're using the letter R because it's sort of like a radius. Because as you draw a circle, or as you draw an angle, you're essentially drawing a circle in a way. So R being the radius of said circle. Drawing this one more time. 2 root 3 to the right, who cares? Like, I don't care if you draw it in the perfect position. What matters is that you know that the base of the triangle is 2 root 3. The x coordinate is the base of the triangle, and then the y part is the height of the triangle, and therefore you're trying to find the hypotenuse. 2 root 3 squared plus -1 squared equals c squared. So you might struggle with that in your head. You can plug it into a calculator. The answer is 12 plus 1, because it's not -1, because the negative times a negative will cancel. 12 plus 1 is 13. You take the square root and you end up with root 13. Now, with all that information, you can, I know it's messy here, I know it's messy, and maybe I can be a little neater, but with that information now, you have the opposite, the adjacent, and the hypotenuse. You see? And now we could, the question didn't ask for it, but we could solve for the trig values using SOHCAHTOA. Let's continue on. So, find sine, cosine, and theta and tangent given the point. Rationalize the denominator when applicable. So, these questions are not written the best, I will admit. This point, given the point on the terminal side, okay? Just like the questions above. But the numbers are a little nicer here. They're whole numbers as opposed to 2 root 3. So please remember that you don't need to plot it. You're creating a triangle. This is the base, -1. This is the height, 3. And this is the R. Now you might be wondering, how does a triangle have a length of -1? Well, it's not actually, I don't mean to blow your mind 13 minutes into this video, but the triangle is just a mental visual to help you understand the trig functions, okay? It's not like this end-all, be-all, okay? I'm not trying to blow your mind, but just, you can have a base of -1. Just deal with it. I know that's not like the best, I know that's not the teacher, not the most teacher thing to say, just deal with it, but to be honest, just deal with it. So R equals the square root of 10. So if we know that now, we can find sine, cosine, and tangent. Sine is 3 over root 10. Rationalize. And we get 3 root 10 over 10. Cosine is -1 over root 10. Rationalize. And we get -root 10 over 10. Tangent is opposite over adjacent, and we simply get -3. I did that a little quick, but just rewind it 20 seconds and review, right? SOHCAHTOA to create those fractions. I haven't asked a question yet, so let's go ahead and ask a question on this guy, but I'll go ahead and get you set up here. We're creating a triangle. Now, this is an angle after all. You know, I just drew the triangle out of thin air, but, you know, -4 is to the left, and -3 is down, like that. I can already imagine that in my head. I don't know if I'm assuming too much of you, but that's why I want to draw the triangle like this. Because it represents, if this is the origin, if this is 0, 0, you know, there's a graph here. But I don't need to draw all of that. I just know that there's a triangle with a base of -4, because that's the x value, the horizontal change, and a height of -3. And this is theta. Okay? Theta is always there at the center, because again, this is a graph, and theta is always that point at the center of the graph, at the origin. So, -3 squared plus -4 squared equals c squared, or no, let me stick with r, our radius. That's 9 plus 16. You might already realize this. You guys have seen a 3, 4, 5 triangle a lot of times in your life. It just comes out to a 5. If you haven't noticed that pattern, start noticing it. If you have a 3 and a 4, the other side is 5. Well, if the legs are 3 and 4, the hypotenuse is 5. It's the hypotenuse that must be 5. Okay. Anyways, I have opposite, adjacent, and hypotenuse. These fractions are going to be nice. Ugh, shoot, I just labeled them for you. Whatever. Easier answer for you. Okay. Sine, cosine, and theta. Give me all 3 of them. I'll type out the multiple choice options somehow. I'll figure it out later. Answers on screen. What is sine, cosine, and tangent of this triangle? Okay, so the one place that you could have gone wrong as you chose your answer is dealing with the positives and negatives. We have a -3 over a +5 for sine. We have a -4 over a +5 for cosine. We have a -3 over -4, giving us a +3/4. For the sake of time, I think I won't do that last one. Yeah, for the sake of time, I don't think I'm going to do the last one right this second. Let's go ahead and skip down to the end here, and this video will be under 20 minutes. Oh, I just got disconnected. Please connect quickly so I don't have to pausing the video real quick. Alright, a freaking century later, I know I just cut and all of a sudden, whoa, something, it's my freaking iPad would not connect to my, anyways. Alright, so, suppose that the point XY is in the indicated quadrant. Decide whether the ratio is positive or negative. I did not write these questions. These questions are poorly written. The ratio. Could we be speaking any more generically here? Did my Apple Pencil just die? No way. Pausing again to not waste your time. Okay, so the ratio, sine, cosine, and tangent, okay? We're deciding whether sine, cosine, and tangent are going to be positive or negative. If we're in quadrant 4, and this is the y value, if we're in quadrant 4, that means we're to the right and we're going down in order to be in quadrant 4. I guess we're finding that ratio. Maybe I misspoke. The question's not that bad. Is this ratio going to be positive or negative? The point, here's x and here's y. It's going to be a negative y over a positive x, and the result will be negative. It's important to note that, right? It's important to note how these fractions are going to reduce and whether the negatives are going to cancel or not. If we're in quadrant 2 and it's y over r, notice that every single time, r is always positive. R is always a positive distance. It's the x and y when we go left a negative x or down a negative y that causes a negative value. But R is always positive, and we're in the second quadrant, so we went up to a positive y value. So we have a positive y over a positive r. The result is positive. So let's end with this question. We're just over 20 minutes. Let's end with this question. Will this be positive or negative? We are in quadrant 3, and as a reminder, R is always positive, but if we're in quadrant 3, is this x value positive or negative? And as a result, is this fraction positive or negative? Answers on screen. Because we went to the left, it's a negative x value, but R is always positive, so the result is negative. And just to conclude the relevancy of this, as we find our trig values, especially up here, right? Especially up here, we were getting positive and negative solutions. So that does truly play a role, right? Positive is definitely different from negative. All right. With that said, thank you for watching. Sorry that this is a late upload, but at least there's an upload. I'll catch you later. I'll see you in class. Have a good one.